Section 5.3 deals with graphing radical functions, and we're going to keep it really as basic as possible here. For example, 1a, we're just going to graph square roots. They ask you to go ahead and make a table of values. We're not even going to worry about that on these. Whenever you have a square root function, the 2 points we're going to be working with are 0, 0. And then if I plug in 1, the square root of 1 is 1. So whenever I have a square root function, I'm going to go ahead and put those 2 points there. 0, 0, 1, 1. And then if we want to go crazy, which I guess we can put the point 4, 2. So the square root of 4 is 2. Okay? You can't take the square root of negative numbers. You can, but you end up with imaginary numbers, which we can't graph. So we're good with those 3 points right there. Go ahead and make a graph. It's going to look something like that. All right? Your square root function, whenever we graph it, is always going to look like this half curve going off to the right. Okay, that is your parent function, unless like if we have some transformations going on. From here, we want to answer some key pieces of information, domain and range. Domain is your x value, so you start with your smallest x value, 0. Since I touch 0, it's a bracket, and then it goes to the right for forever, so we are going to infinity. Range, start with your lowest y value. In this case, that is 0 as well. Go to the right for forever, so we are going to infinity. Actually going up for forever, so we're going to infinity. Increase, decrease, when are we going uphill, downhill? If I look at this graph, as I walk from left to right, we are going uphill the whole way. So from 0 to infinity, we are going uphill. At no point are we going downhill, so we are never decreasing. I'm going to leave that as a not available. All right, so that's your parent function right there. From the parent function, we can do some shifts, transformations, and they follow the same rules we had before. So the number out front would be a stretch. Plus or minus under the square root would be left to right. Plus or minus outside would be up, down. In this case, we just have a stretch by 3. So you could take all your points from the first one, just multiply them by 3. So 0 times 3 is 0. 1 times 3 is 3. And then we're at 2. 2 times 3 is 6. And there's our graph for 3 square roots of x. Domain range, same deal. Start with your small x. We're going from 0 to infinity. Range is my y's. We're going from 0 up to infinity. Increasing, we are going uphill the whole way. So from 0 to infinity, we're going uphill, and we are never going downhill. All right? So that's the basics for a square root function. On the try it, they want you to identify the transformations and make a rough sketch. Again, like I said, under the square root is left or right, and it's opposite of what you think. Outside is up, down, and you just do what it says. Okay, it's the same deal with every other function we've done this year. Cube roots. Again, they want you to make a table of values. I'm not going to do that. For a cube root, you're always going to have the point 0, 0 for the parent function, 1, 1. And then a cube root, we can actually take the cube root of a negative number. So I'm going to go with negative 1. Cube root of negative 1 is negative 1. So I'm going to go ahead and put those 3 dots on my graph. 1, 2, 3. And then as far as a cube root is concerned, it is always like the smashed s. Okay, so we go through all of these values. Smashed s like that. Okay? Domain range for a cube root. Okay, so whenever I see a cube root, you have the smashed s. Domain and range are easy. We're going from negative to positive infinity for both the domain and the range. Okay, we go left, right, up, down for forever. Increase, start to the left, walk to the right. I'm going uphill the whole time. So again, negative to positive infinity. Decrease, at no point are we ever going downhill. So that'd be a not available. B, transformation here. So you have the 2 out front. That's just going to be a stretch by 2. And again, you're just taking your points from the previous example we did, and multiplying by 2. So negative 1 times 2 is negative 2. 0 times 2 is 0. 1 times 2 is 2. And then you still have this smashed S going on. So something like that. And then our domain, range, increase, decrease would all be the same as they were before. Okay, it's all reals for the domain and range. Goes left, right forever, up, down forever. And then we are walking uphill for the whole thing. All real numbers. Got on the try it. For these transformations, we're about left, right, up, down. Under the radical is going to be my left, right. Opposite what you think. So this one is left 3. Outside, up, down, you just do what it says. So if it's minus 5, we are going down 5. All right. For example 2, I would never ask you to graph this by hand. Okay. So what you can do is if you have a graphing calculator, you can actually use the graphing calculator. Or if you don't have one, you can go to desmos.com, which, depending on who you had first semester, we introduced a bunch of students to this. So if you go to desmos.com, we can go ahead and type this in. Actually, first, before I graph it, you need to be able to tell me what the transformations are. Okay, so without a graphing calculator, you need to be able to tell me that in this we have a stretch by 2. We are going left 3, and then we are also going up 5. Okay, so without a graphing calculator, you have to be able to tell me that. If you were ever asked to graph this, so actually show the graph, you would be allowed to use a graphing calculator to actually graph it. So the way we're going to do that, you just flat out type it in. So you got y equals, we have the, let me see, All right, to graph this, you go ahead and type in y equals, and we're just going to type exactly what it says. So we got 2. You have the square root, so I'm going to type in SQRT. That's for square root. We got x plus 3. And then if I hit the right arrow, we have a plus 5 going on. Okay, so there's our graph right there for the square root. It looks roughly what we feel like it should. Okay, you have the half going on. If it were a cube root, you would expect the S, but since we have the half going on, we're good with that. And then from there, you should be able to tell me domain, range, and then the increasing, decreasing. So looking at that, they went left 3, up 5. So if I make a rough sketch of that, we're left 3, up 5. And then it looks something like that. So domain. My smallest x value is negative 3. We're going to infinity. My range, my smallest y value is a 5 going to infinity. And then we are going uphill for all of it. So from negative 3 to infinity. And we are never decreasing. Okay, so that's example 2. For the try it, go ahead and try doing one on your own. Okay, use Desmos, get familiar with that. Okay, absolute last thing is writing the equation from the function represented. So the big deal here is you need to be able to identify what type of graph we got going on here. Okay, so right away when I see the S, I realize that, hey, we are using a cube root. Okay, so I got the cube root of x. You look at it, our center is still 0, 0, so I'm not adding or subtracting anything. Okay, there's no shifts left, right, up, down. The only thing occurring here is that instead of going right 1, up 1, with this point right here, since we're going right 1, up 2, I have to have a 2 out front. All right, that would be our equation. You're going to do the same thing for the try-its. On the try-its, I'll let you know right now, there's no stretch going on. Okay, the only thing the try-its have going on are shifts left, right, up, down. So you would have to put in the appropriate pluses or minuses in there.